Hey guys, welcome back to Math Principles. Last couple of times together, we've been talking about different ways to solve quadratic equations, and something that we've been using is square roots. Well, I want to talk a little bit more about square roots because they're going to be really integral in a couple of the approaches that are coming up. Okay, so first off, let's talk about what a square root actually is. If I were to ask you what's the square root of 9, I'm willing to bet that everyone watching this video could tell me that the square root of 9 is 3. If I ask you why, you would tell me because 3 squared equals 9. Okay, but there's something else that some of you may overlook, and I'm willing to bet that about half or more of you would recognize it, but a few of you would probably miss this one. We could also say the square root of 9 is negative, because if I take negative 3 and I square it, okay, negative 3 times negative 3, a negative times a negative is a positive, which still gives me 9. So I can take these two and I can use these to kind of put together a definition of what it means to be a square root. The square root of a is equal to b if b squared equals a. So anything that you can square right here, square, to get back to what you wanted to have in the first place. So whatever's underneath that root, if you square it, square this value, and you get back underneath that root, then that means that that's going to be your square root. Okay, now, if we want to put a proper mathematical definition on it, here we go. Okay, the square root of any number or any value a is the value b, such that b squared equals a. Okay, now over to the side here, got a whole bunch of really fun numbers. Okay, I've got 1, 4, 9, 16, 25, 36, 49, and a whole bunch more. These are called perfect squares. We'll talk more about these each in a minute. But where these come from, okay, if I do 1 squared, I get 1. If I do 2 squared, I get 4. If I do 2, how's it doing that? And if I do 2 squared, that gives me 4. If I do 3 squared, it gives me 9. If I do 4 squared, that gives me 16, so on and so forth. So each of these is what results if I square the integers. Now, I want to use these to find the square roots of these values below. Okay, so for instance, if I ask you for the square root of 25, okay, you're going to tell me that that's equal to 5. Okay, but one thing that we want to keep in mind is it could be positive 5 or it could be negative 5. So we use this symbol, plus or minus, in front of that 5. Okay, and that says both positive and negatives, because like we talked about with the very first example, square root values can be positive or negative. Now, if I look for the square root of 121, okay, so 5 squared is 25, 36, or 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. The square root of 121 is going to be 11. And don't forget, it's plus or minus 11. Okay, and then finally, square root of 49, that's going to be equal to plus or minus 7. Okay, so those are pretty straightforward. Now, a couple of things we want to keep in mind. Okay, hopefully we notice. Each of these roots can be positive or negative. Okay, also, each of these numbers have integer roots. The numbers underneath those roots are what we call perfect squares. Okay, so all those numbers on the far left side, the examples that we just looked at, those are called perfect squares because they are numbers that are formed by squaring the integers. Now, not every single number that we can think of is going to have an integer root. And it is possible to simplify some of these roots, just even though the numbers underneath those roots are not perfect squares. Okay, here's how. So for instance, I've got the square root of 50 right here. Okay, if I want to take the square root of 50, if I look on this list, I'm not going to find 50 anywhere. Okay, but what I can find are numbers that divide into 50. So I'm going to look at this list, and I'm going to try to find a number on this list that divides by 50. And if I look up, well, someone's going to say 100. And what we want to be careful about is that we're not talking about numbers that 50 divides into. We're talking about numbers that divide into 50. Okay, and the biggest number that can divide into 50 is up here at 25. Okay, so I'm going to use that. And I'm going to say the square root of 25. I'm going to split this 50 up. Okay, so 25. And how many times does 25 go into 50? Well, it goes in twice. So I break it into the square root of 25 and the square root of 2. Now, the square root of 25 is plus or minus 5. So I'll bring that down. Now, 2 is not a perfect square. It doesn't have an integer root. So I'm going to leave that underneath that square root. And I'll have plus or minus 5 times the square root of 2. Okay, and this is the simplified form of the square root of 50. Okay, let's try it again. Let's look at number 5 here, and we have the square root of 20. So I want a perfect square. So number off that list off to the side that divides evenly into 20. And I'm going to have to go pretty far up to find it. And the biggest number that fits into 20 is 4. So I'll break this into the square root of 4 times, what does 4 multiply by to give me 20? Well, it multiplies by 5. Now, the square root of 4 is plus or minus 2, and bring down that square root of 5. And there we go, plus or minus 2 times the square root of 5. Now, the question often comes up, how do I know when we're finished? How do I know that it's simplified as much as it can possibly be? Well, what you want to look for is that number that's still underneath that root. Okay? Are there any perfect squares that divide into it? Well, 5 is not a perfect square, and if I look at this list, I'm not going to find any numbers up here that divide into 5. So this one's as simplified as it can be. Same kind of thing with that 2. 2 is not a perfect square, and there are no perfect squares that divide evenly into 2. Okay, so let's look over here at example 6 with 72. Now, if I look at 72 and I try to find a perfect square that divides evenly into it, someone's going to say, let's use 9. And that's fine. We can use 9. Okay, so we can split this into the square root of 9. And 9 times what gives me 72? Well, 9 times 8 gives me 72. And then the square root of 9 would be that plus or minus 3 again. And then I can bring down that square root of 8. Okay, but 8. Okay, if I look at 8, hopefully we recognize that even though the 8 isn't a perfect square, 8 does have a perfect square that divides evenly into it. I could split that up into the square root of 4 and the square root of 2. So I'd have plus or minus 3 times plus or minus 2 times the square root of 2. Okay, and I can multiply the 3 and the 2 and say plus or minus 6 times the square root of 2. Now 2 is not a perfect square, but there are no perfect squares that divide into it. So this one would be finished. However, there is a faster way. If I find a larger perfect square that evenly divides 72, we can do this in fewer steps. Here's the trick. Go to the list, find 72, okay, or find the next number smaller than 72, and here we are at 64. Okay, now try 64 and see if it divides evenly into 72, and it doesn't. Work your way then up the list. 49 also doesn't divide into 72. 36 does divide into 72. So this is the one that I'm actually going to use. I'm going to come down here and I'm going to split this up into the square root of 36, and 36 times 2 gives me that 72. And then the square root of 36 is plus or minus 6 times the square root of 2. So we get to the same answer, and we get there in fewer steps. Now, guys, you can start with smaller numbers if you want to, okay, and you'll have to keep reducing, maybe, or find the largest perfect square that evenly divides that number underneath the root, and that'll allow you to simplify that root a whole lot faster. All right, let's take it a little bit further. Let's keep some things in mind, though. Okay, remember, roots can be positive or negative, since a positive times a positive equals a positive, and a negative times a negative also equals a positive. Whew. Negative times a negative equals a positive times a positive equals a positive. So if I'm multiplying something by itself, I'm always going to get a positive value. So what if the number underneath the root is a negative? For example, I've got square root of negative 9 here. Okay, we can't take the square root of negative 9 with real numbers, since 3 squared equals 9, and negative 3 squared also equals 9. Okay, so for this reason, I was invented. Okay, now I'm not talking about me, Mr. Henning, your teacher, I'm talking about the number I. Okay, someone made up this number, I, and they said, let I equal the square root of negative 1. Okay, because watch what happens here. If I take this square root of negative 9, okay, and I split this up so that I have square root of 9 and the square root of negative 1. Well, the square root of negative 9 is plus or minus 3. And the square root of negative 1, if I let it be I, I've just totally eliminated the square roots. So this guy invented I, just made it up out of the blue so that he could do his algebra. Okay? Then what they started realizing is this letter I, this number, shows up in a lot of different calculations. it showed up first in physics, and then they started seeing it involved with a lot of electricity type of equations. So it's not just something that they made up and then forget about it. It's actually something that can be very, very useful for a lot of different fields. Now, we can use this for our purposes. Let's keep it simple. We can use this to simplify the square roots of negatives. So for instance, right here, I've got the square root of negative 100. So what we do is we take the negative and we put it at the end. Okay, the square root of negative 1. Okay, then that 100 is now positive because 100 times negative 1 gives me that negative 100. Then we take the square root of each of them. So the square root of 100 is plus or minus 10, and the square root of negative 1 is I. So the square root of negative 100 is equal to plus or minus 10i. Okay, the square root of negative 8. Okay, so I'll take the square root of 8 and the square root of negative 1. Well, the square root of 8 is not a perfect square, but I can split this up into the square root of 4 and the square root of 2. Remember, we find the largest perfect square that divides evenly into that 8. And then I'll just bring down that square root of negative 1 for now. You know what that looks like? Square root of 4 in it. Let's fix it. There we go. Okay, now the square root of 4 is plus or minus 2. The square root of 2 doesn't simplify, so I just bring it down. And the square root of negative 1 is I. Now, one little detail here. We like to put the square root, the radical, at the very, very end of our expressions. So I'm going to move some of these terms. I'm going to say plus or minus 2i square root of 2. And the reason that we do that is really simple. Okay, some of us have sloppy handwriting, myself included. Sometimes it's not very clear if that square root goes over the I or if it doesn't. Okay, now if we put the square root at the end, there's no question about where it stops and where that radical ends. We know that it's just the 2 underneath the root. So we always put the square root at the end of our expression. No matter what order we simplify it in, we always put that radical at the end. Okay, how about the square root of negative 40? Okay, so I'll bring down the square root of 40 times the square root of negative 1. Now 40 is not a perfect square, but I can find a perfect square that evenly divides into 40. Okay, I can split this into the square root of 4 and the square root of 10. Okay, and I'll just bring down that square root of negative 1 for now. Now the square root of 4 is plus or minus 2. The square root of 10 will leave as the square root of 10. And the square root of negative 1 is I. So now we're going to shuffle our terms. Okay, we'll put the plus or minus first, any integers, then I, then a radical. And there we go. Okay, last up, I have the square root of negative 11. Okay, now this one, it's going to seem tricky, but it's actually quite simple. Okay, I'll bring down the square root of 11, bring down the square root of negative 1. Now, 11 is not a perfect square, so I'm just going to bring this down as plus or minus the square root of 11. Okay, then the square root of negative 1 is that I. Now, all we're going to do here is move that radical to the very end. So plus or minus I times the square root of 11. And there we go. And that's really all there is to it. So when we're simplifying square roots, we find a perfect square that evenly divides the number underneath that radical. If that number underneath the radical is a negative, we also bring out the square root of negative 1. And the square root of negative 1 is I, and we simplify the rest of the roots. At the very end, we always want to make sure we have a plus or minus first, then any integers, then I if it's needed, and then the radicals at the very end.